All right, so on this video, we are looking at learning objective 5, which is to explain the ways that we can separate a mixture into its components. So mixtures are separated by physical changes. So when we are looking at a mixture, we are using physical. Let's take into account the physical properties that make up the substances in the mixture. So some of the physical properties that we can use to separate, the first would be density. So again, we're not wanting to change what the stuff is in the mixture. We're wanting to separate it out. So we're not wanting to change that stuff. We're just wanting to separate it out. So again, we're going to be using these physical changes, not chemical changes, because the chemical change is going to change the actual chemical composition. So with density, is there a difference in the density is what we really want to ask. So is there a difference in the density? If there's a difference in the density, we can take that into account. So like we can take a heavier, more dense substance and separate it from a lighter, less dense substance. So that's the first one. The second one we can use is like the shape of matter. So is it ground up? So is it ground up like salt, or is it like cubes of salt? Like, so is it like actual like solid chunks? Because we can definitely pick out like solid chunks, but when it's ground up all together, we can't kind of separate that out as easily, that type of thing. Okay. So shape of matter is a good one to use if you're going to use that one. We can do state of matter. So what states of matter am I working with? Am I working with a solid that's dissolved in a liquid? Am I looking at a solid and a solid that's been dissolved in a liquid but it's not actually dissolved in that liquid? Am I working with a solid liquid mixture? Am I working with a liquid mixture? So what state of matter am I working in? That would be another physical property that we can look at. A fourth type of property that we could look at is the boiling point or the melting point. And mainly, I'm going to say that we're going to look at the boiling point. So the boiling point. And a lot of times I will abbreviate this as BP. So what's the boiling point of the mixture, or what's the boiling point of a substance within the mixture? Is there a difference in the boiling point? So if you were in class today, so if there's a difference in boiling point. So we talked about in class today distillation. So when we distill something, there's a difference in those boiling points. So I did the demo of the cherry Coke being distilled. The cherry flavoring is what comes off first because it has a lower boiling point than water, and then water would come off after the cherry actually all comes off. So, and that temperature rises again. So if we were looking at it, the temperature of the cherry flavoring that's in cherry Coke comes off at about 90 degrees Celsius. Water wouldn't come off until about 100 degrees Celsius. So boiling point is another really great one that we can look at. The fifth one is magnetic properties. Magnetic property. Is there a substance in the mixture that will be attracted to a magnet? You know, the one that really comes to mind when you're talking about magnetic properties is iron, right? We know that iron is very, very magnetic. So if we've got iron shavings in some sort of mixture, we can pull the iron out of the mixture. So then we are going to start talking about some separation techniques. This is going to be a pretty long learning objective. So just bear with me, okay? So the first separating technique that I can use is I can filter. So filtering is one of the first types of separation techniques that we can use. So this is where we have a flask, right? I can't really draw on this. And we've got a funnel on the flask. Right. Now, inside the funnel, right? So inside the funnel, we're going to have a filter paper. And our mix goes on top of the filter paper. So our mixture goes on top of the filter paper. And what's going to happen is we're going to let that water, so liquid, so the property that we use to filter something. So a lot of times we have the solid liquid mix. So we have the solid liquid mix. So then the solid becomes what we call the residue. So the residue that's going to be left on the filter paper. And then the liquid is what we call the filtrate. This is the part that kind of comes out and into the flask. Okay, so the filtrate is going to go through the filter paper and into the flask. And then the residue is going to be stuck on the filter paper. Okay, so on the filter paper, we have the residue, the mixture goes into this, the liquid starts dripping through the filter paper and into the flask, and then the filtrate is what we have that is coming off. I can't spell because I let the L out. So the filtrate is what we have on the bottom. Okay, so this is filtering. So filtering, we're using the solid liquid, we're using the state of matter, so solid to liquid. So if you've got a solid that's in a liquid, you filter it to get it separated. The second type of separating technique is decanting. And this is very similar to filtering. We can always do decanting and filtering at the same time. Okay, so decanting is where we have, so the property that we use is the state of matter or the density. So this can be used for solid liquid, or we can use it for a liquid. It doesn't matter. So with liquid, we're going to use more of density. In solid, we're just taking into account the state. Okay. So if we've got a solid and a liquid mixed together, we can let that sit there for a really long time. And if we let it sit long enough, that solid is going to fall down to the bottom of the flask. So then we'll have solid at the bottom of the flask, liquid on the top of the flask. We can then pour out the liquid and leave the solid inside. Then we're going to have to filter to get rid of the rest of the water, right? Or we can say we've got liquid, so we let them sit. We have them stacked on top of one another because they have differences in density, right? And then we can pour the lighter liquid off of the top of the heavier liquid. Okay, so the way that this would look, let's see, we've got a test tube here. And we've got a liquid here, and then we have another liquid on top. So we've got two different liquids, right? I can color these different colors. So this liquid is less dense. And then on the bottom, we're going to have the more dense liquid. Or here we could have a solid. Okay. And we just let those sit and separate out. And once they separate out, we can pour off the top layer. Now, if this is a solid, we're probably going to have to do some filtering in here as well. But again, this is another way that we can separate liquid or solid. Okay, and again, this is using state of matter or the density. So then number 3 we can use evaporation. So if we're evaporating, we're also boiling. It's the same kind of thing there. Okay, so the property that we use to separate is the boiling point. Now, essentially, when we're using boiling or evaporation, what we're doing is we're isolating dissolved solids. So we're really using this for things that have been dissolved in water, essentially. So solids that have been dissolved in water, and we're going to evaporate or boil those off. You will be doing this in your lab. So the property used to separate is the boiling point. So we could say it's a change in state. As well. So when we're changing state, we're doing the boiling point. And this is to get all of the water off, this should say off of the mixture, so that you are left with the solids. Number 4, distillation. So again, the property used here to separate is the boiling point. Again, this uses differences in boiling point to separate miscible liquids. What miscible means is it means mixed. Well, so these are liquids that are mixed well, so they don't separate out, that type of thing. Again, the liquids that have the lowest boiling point so in a distillation setup, you have a thermometer. This is what's going to measure the boiling point. So it's measuring the boiling point here. This is what we call the condenser. And it's attached to this piece right here. So this whole thing right here is the condenser. So essentially you have this, it's attached right there. So what this is measuring is the boiling point. So because at this point, it's going to be a vapor. You have a boiling flask that has a Bunsen burner or some type of some type of heat source, essentially. You have water in and water out. So essentially what happens, and I didn't have this set up because I can't get my water to set up to the condenser. So I have water in and water out. Essentially what this does is it keeps this piece cool so that I can condense down into this receiving flask. At 9, you have a vacuum place to where you can attach a vacuum to evacuate any air off, that type of thing, so you have a completely closed system, if that's what you want. So a lot of times you want that closed system. So the whole piece right through here is the condenser. So we're actually condensing the water back down into, or the vapor back down into its stuff. So in the boiling flask, you have the mixture. So you have the mixture in the boiling flask. You add heat to the boiling flask. The thermometer is measuring the boiling point. At the condenser, it's starting to condense back down into its liquid form. And then you have the receiving flask, which in this flask is where the distillate comes in. So we get a distillate, which is the pure substance. So this guy is going to be the pure substance in the mixture. Okay. So that's distillation. The final way to separate mixtures or the final way that I'm going to talk about in class, right, is chromatography. So the property used to separate in chromatography is affinity, which is the attraction or the forces between substances. So affinity is this attraction or forces between substances. This is used mainly for liquid-liquid separation. And essentially what you have is you have your flask. Usually it's like a beaker. And you've got this small amount of solvent at the bottom of the beaker. So this is solvent, which is your liquid, right? So it's a piece of this. And then you have a piece of paper, which is what we call chromatography paper. And you can do this with like any type of like coffee filter, that type of thing. So this is a paper. A lot of times we use paper. Sometimes we use silicone sheets, especially in organic chemistry. And then you have this place on this paper that you've made a dot, essentially. And then this liquid starts rolling up the paper because the liquid is attracted to the paper. So it starts moving up the paper because of the interactions on that. The substance is on this line. So the substance, the mixture. So the mixture is on this line. So the mixture is on this line. And as the water level rises or the solvent level rises, you get the separation of distinct pieces within your thing. So like this would be a pure substance. And this, if we isolated it, would also be a pure substance. So we can see like what things are in the liquid. Now, the higher that we move, the more attracted to the liquid it is. And then the lower that we are, the more attracted to the solid or the paper we are. So we can say the paper is the solid. So this is where affinity comes in. So we separate it based on affinity, which is these forces or interactions between the paper and the liquid and the mixture and the liquid and the solvent. Okay. So these are the 5 types of ways that we can separate a mixture.